You guys ready? So we're clipping the oxygen off of
Awesome.
So what's the temperature now? Tell me how hot it got. Where at? 106, 108. So we went from 77 to 108. So it's not that hot, but it's generating heat, right? So in chemistry, if I put my hand on top of this, it's a closed system now. In chemistry, what do we call a closed system? A bomb. Because there's nowhere for the pressure to go. So an open system, you get a reaction. A closed system, you generate a pressure wave. Okay?
Make it explode.
Well, if I went like that and held it for a while, it would explode because I'm not letting the pressure off the system. Okay? But I'm not going to do it. But you hear the bottle overpressurize and pop out? That's because of the pressure. So all I made, yeah, we're good. Yeah, and then I'll get you to help me again on the next one, okay? Thank you. So all I made was soap, trap the oxygen, and water. So in chemistry, there's a couple things you want to do. You want to know what you're doing. You don't want to generate a poisonous gas because you'll kill yourself. You don't want to make a pressure wave because you'll kill yourself. And you don't want to make hazardous waste because you can poison yourself, right? So you better know what you're doing. I'm going to put this in the sink because it's getting real messy here. All right. So any questions on that? So that was just a reduction. I reduced hydrogen peroxide to water, and I liberated the oxygen. All right. The next experiment. So, let's change gears real quick. So, these peanuts, right? The packing peanuts, correct? So they're basically a foam with oxygen trapped in them, right? As a cushion, right? So long chains of hydrocarbons, you know, in chemistry, I mean thousands and thousands long. So I can liberate the oxygen in there, and I can cut those chains using molecular scissors, right? So here we go. That weird one was a different type of packing peanut, so it didn't work with it. You know what that is? That's just acetone. That's nail polish remover. And all I did was cut off those hydrocarbon chains into that goo that's left at the bottom. Yeah, right? All right. So, let's move on to the next experiment. I'm going to do a combustion reaction. So what do we got here? What are these? Gummy bears. What are gummy bears?
Gold bear. Isn't it?
What are they made of?
Candy.
Candy. What's candy made of?
Chemicals.
Sugar. Don't you like sugar?
Yes.
Okay. All right. So basically, what those gummy bears are is right here. It's 12 carbons, 22 hydrogens, and 11 oxygens. That's all it is, right? So if I take these gummy bears and I eat this, I put this in my mouth and I eat it. Tomorrow, after it's digested, I'm going to breathe out CO2 and I'm going to sweat water out. So this is all this is water and carbon dioxide. But it makes energy that runs our bodies, right? So our bodies are very complicated and the chemistry is a little different. But what our body does is instead of, I'm going to release all this energy at once as heat and light, but our body takes little tiny bites of it, if you want to think of it that way, and takes that energy and hauls it off. It's called ATP, which is biochemistry. And that's what gives you the energy to play soccer or run around or sit on your couch and play video games and think. So without the carbons and the hydrogen and the oxygen,